Alright guys, so what we're going to do today is we are going to solve rational equations. So this is going to use some of the same things we've done in the previous classes with common denominators and things like that. But really it's not going to be too terrible, the actual solving part here. The hardest part for today I think is going to be the applications and the word problems that we're going to look at the end. Alright, so when it comes to solving rational equations, there's really two different methods you can use. Depending on the setup on the problem, one may be easier than the other. The first method is cross-multiplying. So if you just have a fraction equal to a fraction, cross-multiplying is going to be your best bet here. So in order to cross-multiply, I will just multiply this diagonal down. So this would be 9 times x plus 1. And then that's going to equal my other diagonal, which is 3 times 4x plus 5. Then from this point, it's just an algebra 1 equation. 9x plus 9 is equal to 12x plus 15. So 3x is equal to negative 6, and x is equal to negative 2. Now, one thing we need to make sure we do on these equations, just like we've done all year, is we need to check for extraneous solutions. Plug your answer back in and make sure it works. Okay, in this case, if I plug it in, 3 divided by negative 1 is negative 3. 9 divided by negative 3 is negative 3. Okay, this is a true statement. That is my correct answer. Typically, an extraneous solution is going to be one of those excluded values. So typically, it would be a value where you'd be dividing by 0. So like if I got negative 1 as an answer here, that would be an extraneous solution. All right, second method is to find our least common denominator. So let's go ahead and find our least common denominator here. All right, it's going to be 4x. So I want to get every fraction with that common denominator. So I would multiply by 4, multiply by x, and multiply by 4. So that would give me 20 over 4x plus 7x over 4x, and that's equal to negative 36 over 4x. Now what's nice about this method, whenever we add and subtract fractions, we don't change the denominators. The denominators stay. So if the denominators are common, in order to solve this equation, I don't need to worry about the denominators anymore. This is going to be equal as long as whatever's at the top of the equation is also true. So now I can really, once I have that common denominator, I can ignore the denominator and really just solve the numerators. So then at this point to solve, I would get 7x. I would go ahead and subtract that 20, and I get that x is equal to negative 8. So again, common denominators, once you have that denominator in common, because whenever you add and subtract, the denominator doesn't change, all you need to do is solve the numerators once you have the same denominator. Now you can use a combination of these two methods if you want. You could just combine these two together, for example. Let's say I did that, and I got 20 plus 7x over 4x is equal to negative 9 over x. Then if you wanted to, at this point, you could cross multiply, and you'd get negative 36x equals 20x plus 7x squared. It gets a little messier at this point, because then you would have to factor and things like that, but you're still going to get the same answer just by doing a different method. So let me go ahead and finish it out this way though, because this is a good example of an extraneous solution. So if I were to finish this up, I would go ahead and do 0 is equal to 7x squared plus 56x. I would factor out that x. I can factor out 7x and make our lives a little easier. And I would get that x equals 0 and x equals negative 8. Well, now x equals 0, that's an example of an extraneous solution. If I were to plug that back into this original problem, I'd be dividing by 0, which I can't do. So my only answer is negative 8. So again, multiple different ways you could work this out, just depending on which method you think works best for the problem that you have. All right, so let's go ahead and try another one. Again, up to you what method you think is best. I think personally this one is going to be a lot easier to get a common denominator. So x squared minus 9 factors into x plus 3 and x minus 3. So if you look at the denominators that you already have, that common denominator is going to be x plus 3, x minus 3. In order to get that denominator, the left fraction is going to need an x plus 3. The right fraction is going to need an x minus 3. And now I have 6x plus 18 over that common denominator is equal to 8x squared over that common denominator. And then I've got 4x squared minus 12x over that common denominator. So then at this point, we can just solve the numerators. All right, so I've got 6x plus 18 is equal to 8x squared minus 4x squared. And remember, when you subtract that fraction, you're subtracting the entire quantity at the top. So that's going to be a plus 12x. This is going to be 0, 4x squared plus 6x minus 18. Everything here is divisible by 2. And then we can factor. So this is going to factor into, we've got, 2x and x. That should be a minus 3. I mean a plus 3. So that gives me, good. So that gives me my two possible answers. X equals negative 3 and x equals 3 over 2. Now again, we have to make sure we check for extraneous solutions. In this case, negative 3 is an extraneous solution. Because again, with negative 3, if I were to plug that back into the original, I'd be dividing by 0, and I can't divide by 0. All right, so let's go ahead and try this next one. If you feel comfortable, pause the video, try this one on your own. All right, I'm gonna go ahead and do common denominator again. I just think that's a little bit of an easier method on this one. If you want to cross multiply, you are welcome to do that. If you want to move this one over, combine them and cross multiply, you can do that as well. Lots of options here. So my common denominator is going to be x plus 1, x minus 1, which means the left fraction is missing x plus 1. The 5 is missing both of them. Once the denominators are the same, I can just solve the tops. So 7 times x plus 1 minus 5 times x squared minus 1 is going to equal 6. So 7x plus 7 minus 5x squared plus 5 equals 6. It's quadratic, so we need to set it equal to 0. So 5x squared minus 7x, let's see, that's plus 12 minus 6 is equal to 0. Again, we need a factor. So I'll factor this one the long way, just to make sure we're familiar with how these factor. Multiplies to negative 30 and adds to negative 7. I'm going to split the middle into those two numbers. So negative 10 and 3. Then I'll do my grouping. So I end up with two possible answers. X equals 2 and x equals negative 3/5. If I plug both of them in, they do both work, and I do have two solutions to this equation. So those are really just kind of the basics of actually solving these equations. What we're going to do now is kind of move on to some more, well, there's I guess one more, different one that we'll look at. This one's a little bit almost more like a word problem. So we want to determine where this function crosses the horizontal asymptote. So first of all, we do know that's possible. Okay, we've seen graphs that do that. To determine where it crosses, we're really trying to solve an equation here. Okay, the first thing I need to figure out is what is the horizontal asymptote. All right, so in this case, it's same degree. So I divide leading coefficients. So my horizontal asymptote is y equals 2. So I want to know when y equals 2 intersects this function. So I want to know when 2 is equal to 2x squared plus x plus 3 over x squared plus 5x minus 10. So again, I just have a rational equation. I'll go ahead and cross multiply on this one. So 2x squared plus x plus 3 is going to equal 2x squared plus 10x minus 20. If I were to solve this, those 2x squareds will cancel. I'll get 9x is equal to 23, and x is equal to 9 over 23. And then let's say you want to write the coordinates. Well, I already know the y coordinate. The y coordinate is 2. So when x is 9 over 23, this graph is going to cross the horizontal asymptote, which has a y value of 2. All right, so one more that is a rational equation these are actually what we call, I like to call them factoring in disguise. This is actually a question that we are able to factor. Now, if you want to, you can FOIL this whole thing out and you can simplify and you can make a big gigantic mess of this whole thing. But instead, what we're going to do is we're going to actually factor this. And to make this easier to see, we're going to use some substitution. So I'm going to replace what's common in two places in this problem, this 3x minus 1 over 4x, with a variable. All right, I'm going to use a variable other than x, just because if I use x's, it can get a little bit confusing on my actual solution. So I'm going to pick a different variable. I'm going to use the letter u. The reason I'm using u is just because you'll use that later on down the road. So I'm going to let u replace this part here that's repeated. So I'm going to let u equal 3x minus 1 over 4x. So if I do that, I'll get 2u squared minus u minus 6. Well, that's a much simpler question to look at. And hopefully you can tell by looking at that that factors. So that is going to factor into 2u and u, and then I'm going to have a plus 3 and a minus 2. So if I were to solve this, I can solve for u now, okay, because this is still equal to 0. I would get that u is equal to negative 3 over 2, and u is equal to 2. Now again, this is the reason why I don't use x, because you may think you're done at this point. So I haven't solved for x, I've only solved for u. And we don't care about u is, all right? We care about what x is. So now I'm going to go back and replace what I originally substituted. So 3x minus 1 over 4x is equal to negative 3 over 2. And 3x minus 1 over 4x is equal to 2. And now I just have two pretty simple rational equations to solve. I'll cross multiply on both of these. So negative 12x is equal to 6x minus 2. So that's going to give me 18x is equal to 2, and x is equal to 1 over 9. And then on my next one, 8x is equal to 3x minus 1. So 5x is equal to negative 1, and x is equal to a negative 1 over 5. So we're going to see more of these kind of factoring in disguise questions as the year goes on. So anytime you see something kind of in that ax squared plus bx plus c type format, and x is just something other than x, you can replace it with another variable to factor it, and that will make it a little bit easier for you to be able to solve as opposed to trying to multiply and FOIL that whole thing out.